Transactions are a way of grouping related operations to help ensure data consistency and reliability in your applications. These are critical for maintaining integrity across complex operations, especially in healthcare, financial services, and other environments. In InterSystems IRIS, transactions help prevent partial updates and data corruption. In this video, you will learn how to use transactions in both ObjectScript and SQL and understand the best practices that help you avoid those kinds of consistency and data corruption issues in your own code. A transaction must be treated as a single atomic unit of work. That means either all the operations within the transaction succeed together, or none of them do. This behavior is captured in the ACID properties, representing atomicity, consistency, isolation, and durability. Atomicity means all or nothing, while consistency ensures that the database remains in a valid state before and after the transaction. Because of atomicity, the database is guaranteed to end in either the valid state it was in before the transaction began or a new valid state after the transaction completes. Isolation prevents transactions from interfering with one another, and durability guarantees that once a transaction is committed, the changes are permanent. InterSystems IRIS manages transactions directly within the database engine. That means the database itself ensures that your updates either fully succeed or are completely rolled back, even when multiple users or processes are working at the same time. Transactions and concurrency control work together. A transaction defines the unit of work while the database ensures that other processes cannot interfere in a way that would leave your data inconsistent. Before we look at specific syntax, let's understand the general workflow of a transaction. A transaction follows a simple pattern. First, you begin the transaction with a start command. Next, you perform the series of database operations that should succeed or fail together, such as saves, inserts, updates, or deletes. Finally, you end the transaction by either committing all the changes with the transaction or rolling them all back if something went wrong. This framework stays the same regardless of the language you're using. What changes is just the syntax. Now let's apply that workflow to a simple example transferring $100 from one bank account to another. In ObjectScript syntax, here is the typical sequence. To begin a new transaction, use tstart. We then proceed with our database operations. In this case, two account objects are saved after their balance properties were updated prior to starting the transaction. The command tcommit will commit all the operations performed since the last tstart. If something went wrong with either of the saves, trollback1 reverses any changes made during the transaction, restoring the data to its previous state. Behind the scenes, InterSystems IRIS tracks all changes made after tstart. When we call tcommit, those changes become durable. If we call trollback, the system undoes them. That's what guarantees the all-or-nothing behavior of a transaction. For example, we will transfer $100 from account 2 to account 1. With a transfer, you need to guarantee that either both account balances are updated or neither account balance is updated. We open both account objects and calculate the new balances, then start the transaction and attempt to save each object. Each %save returns a status value. If both saves succeed, we call tcommit, making both balance changes permanent. If either save fails, we call trollback1, which undoes the most recent transaction level so neither balance is changed. We use trollback1 here because it rolls back only the transaction started in this code block. The trollback command without the 1 would cancel all active transaction levels, which is appropriate only when you are certain your code controls the entire transaction. Let's take a look at the syntax in SQL. InterSystems IRIS uses the ANSI standard syntax. The same transfer operation can be expressed in SQL by starting a transaction, running the update statements, and then committing the transaction. If one of the statements fails, you can issue a rollback to undo the changes made within the transaction. Just like in ObjectScript, the transaction ensures that the updates are either committed together or rolled back together. This makes transactional behavior consistent whether you are working with objects or relational data. InterSystems IRIS supports nested transactions in ObjectScript. Each call to tstart increases the transaction level, and only the final tcommit permanently commits the work. We can see this in the terminal using $T_level, which shows the current transaction depth. After the first tstart, $T_level is 1. A second t-start increases it to 2. If we run t rollback 1, only the most recent level is undone, and $t level drops back to 1. The outer transaction is still active. If we then call tcommit, the level returns to 0 and all remaining changes are committed. A full t rollback, however, immediately resets the level to 0 and cancels all active transaction levels, undoing all changes made in the transaction. SQL transaction support in InterSystems IRIS follows the ANSI standard. You can start a transaction, commit it, or roll it back using start transaction, commit, and roll back. While SQL allows transactions to be started within an active transaction, it does not support nested commits the way ObjectScript does. A commit always finalizes the entire transaction. However, SQL and InterSystems IRIS provides savepoints, which allow you to mark specific points within a transaction. If an error occurs partway through, you can detect the failure and roll back to a save point, undoing only the work performed after that point while keeping earlier changes intact. Here are a few tips for using transactions. Keep transactions short to reduce how long locks are held, since long-running transactions can block other processes from accessing the same data. Always check return statuses when saving data so you can decide whether to commit or roll back rather than risking inconsistent results if an operation fails. Avoid unnecessary nested transactions because additional transaction levels increase complexity and make rollback behavior harder to reason. Use transactions where consistency matters. For example, when multiple updates must succeed or fail together. Using transactions in situations where they aren't needed can introduce unnecessary overhead without providing additional benefit. Transactions are a powerful feature in InterSystems IRIS that help ensure your applications remain reliable and your data stays consistent. Whether you're working with ObjectScript or SQL, InterSystems IRIS provides robust transactional support to help you build safe, dependable systems.